At around 100 feet, the pressure is already several times greater than it is at the surface. A trained diver can reach this depth with appropriate equipment and training, but it isn't simply a matter of swimming downward. Every additional foot increases the surrounding pressure. The sunlight is also fading rapidly, and the underwater environment starts becoming darker. And this is still just the beginning. At around 500 feet, things become much more extreme. This is far beyond ordinary recreational diving. Specialized technical divers may use carefully planned gas mixtures, complex equipment, and extensive training. But there's another problem. The deeper you go, the longer it can take to safely return to the surface. At these depths, diving becomes less like swimming and more like managing a complex life support system. Now we reach roughly 1,000 feet. The pressure here is around 30 times the pressure at the surface. For a human body, that's an extreme environment. Without specialized equipment and careful pressure management, humans cannot simply survive at this depth. This is where the idea of normal scuba diving starts to disappear. To go deeper, we need a completely different approach. At around 2,000 feet, one remarkable technology becomes especially interesting: the atmospheric diving suit. Instead of allowing the diver's body to experience the full surrounding pressure, the rigid suit maintains a much more manageable internal environment. The suit acts almost like a tiny personal submarine. But even these suits have limits. And if we want to go thousands of feet deeper, we need something much stronger. This is where manned deep-sea submersibles become incredibly important. Inside a submersible, the crew sits inside a pressure-resistant hull. Outside the vehicle, the ocean is pushing with enormous force. Inside, the crew can maintain a much more comfortable atmospheric environment. Powerful lights reveal only a tiny section of the darkness ahead. And the deeper the vehicle travels, the more important every piece of equipment becomes. A small problem at the surface can become a major problem thousands of feet underwater. Now imagine going beyond 10,000 feet. At this depth, the ocean becomes almost completely dark. Sunlight cannot reach this far down. Humans don't need to personally enter these depths to explore them. Instead, scientists can use remotely operated vehicles, or ROVs. These machines can descend into extreme environments while operators control them from much safer locations. Their cameras, lights, and scientific instruments allow us to explore places that would be incredibly difficult for humans to reach directly. More than 12,000 feet below the surface, we're reaching the general depth range of the deep ocean. The pressure is enormous. The environment is dark, cold, and completely isolated from the world above. A deep-sea submersible must be engineered to withstand this pressure. Its pressure hull is one of the most important parts of the entire vehicle. Every window, seal, cable, and mechanical system has to work under extreme conditions. Down here, technology isn't just helping humans explore, it's keeping them alive. But the ocean gets even deeper. At Challenger Deep, in the Mariana Trench, the seafloor is roughly 36,000 feet below the surface. That's almost 7 miles straight down. Imagine placing the tallest mountains into the ocean and still having miles of water above them. Only specially designed deep ocean vehicles can reach these extreme depths. And when a submersible finally reaches the bottom, the world outside its window looks almost completely alien. So how deep can a human really go? The answer isn't simply a number. It depends on the equipment, training, breathing system, and mission. Humans aren't naturally built to withstand the enormous pressures found in the deepest ocean. But technology has allowed us to travel farther than our bodies ever could on their own. From diving equipment to atmospheric suits to massive submersibles and robotic vehicles. The deeper we travel, the more extreme the ocean becomes. And every few thousand feet reveals just how little of our planet we've truly explored. Because the deepest ocean isn't another planet. It's right here on Earth. And we still have so much left to discover. Subscribe for more incredible science, Earth and exploration stories, and stay curious. Waterwave Microscope.